Hey audience, last time I finished up this project, or at least I thought I did. While I was playing with it, I put my switch bounce detector on the clock output just to be sure that my clock multiplexer was actually glitch-free. And I found that, unfortunately, it was counting wrong. Now, I didn't see any glitches when I put it on the scope, and what's even stranger is that it wasn't counting multiple rising and falling edges like it would if there were glitches. It was counting multiple times for a rising edge without counting extra falling edges. Like there were two rising edges in a row with no falling edge between them, which doesn't make any sense. So what had happened was I'd had a few inverters left unused, and I used a couple of them to buffer the output of the clock multiplexer. But those inverters were from the CMOS 74HC04 chips, and the multiplexer was made out of TTL 74S series chips. And the switch bounce detector was also made with TTL 74LS series chips. When I probed the TTL outputs of the clock multiplexer, suddenly the bounce detector started counting correctly. So the problem was that I had assumed that the 74HC series chips would be compatible with 74S and LS series chips. I figured they're both 7400 part numbers, they're pin compatible, they're all 5 volts, but it turns out that the logic levels are slightly different. From this logic guide from TI, we can see that the minimum guaranteed output high voltage from a TTL chip is actually lower than the minimum required input high voltage for CMOS chips. I've typically seen TTL chips output a higher high voltage than the minimum required output high voltage, and they can generally drive these CMOS chips by accident, which is how I managed to get away with it when I used the CMOS chips for my LED buffers. But even still, something about the voltage incompatibility made them not work for buffering clock signals. I don't know exactly what was going on electrically, but it looks like I can swap the 74HC04 chips for 74HCT04 chips and then just get it working. They're still CMOS chips, but they have compatible voltage levels with the TTL chips. And sure enough, after swapping the chips, everything started working. Except now the pull-down resistors aren't strong enough and the inputs are floating high. I figured this wouldn't happen because they're still CMOS chips, and they should have a high enough input impedance to be pulled down by large pull-down resistors, but I guess not. In order to find out what resistors are needed to pull down the inputs, I attached a 100K potentiometer between ground and the input, which puts it in parallel with the existing 100K pull-down resistor. Then I can just turn it until the LED goes out and measure the pot to see what I need to pull it down. And 4.5 kilo ohms. No thank you. 5 volts over a 4.5 kilo ohm resistor will push over a milliamp, which is more than I would like to draw from my TTL circuits, especially when the output is high. So the solution here is just to stick the 74HC04 back in there and take the clock output directly off of the 74S37s instead of buffering them through inverters. The 74S37 is designed to have a high fan out anyway, so it should be fine. There was never really any reason to buffer it. Using the 74HC04s as buffers for the LEDs will probably come back to haunt me at some point, since the TTL outputs aren't guaranteed to be able to drive them, but it's too convenient to use them for the ability to pull the inputs down with large resistors, and it seems to work okay. But anyway, I learned something new and I know what to avoid for next time, so I'll see you then.